Okay, so we will discuss what are vectors, scalars, and then one more thing I have written here. So you will see what is that. Okay. Anyways, so what is scalar quantity? First, we will discuss what is a scalar quantity. But why do we discuss a quantity? I mean, why do we differentiate a quantity into vector and scalar? Okay, that is the first fundamental question. Because you think like this. Okay, simple example I would like to give you. That is, suppose we have a lot of physical quantities. Okay, what are the physical quantity? For example, this is a chalk piece. I mean, this is a marker. And is it a physical quantity? No. What are the physical quantities? The quantities which exist in, I mean, which we deal regularly. So those are physical. Okay, the physical quantities actually they are like every quantities which we discuss in physics. So which are physical quantities. For example, so better we explain it in terms of examples. Okay, by using examples, by the help of examples. First one, force is a physical quantity. Mass is a physical quantity. Velocity is another physical quantity. I think you got it. What are those things like which we discuss in physics? So which are known as physical quantities. And one physical quantity which is actually scalar. When we say that it's scalar, it's very simple. It has only magnitude. Only magnitude. So then there is another question. What is magnitude? What is magnitude? Okay. So I would like to give you another this one. What are vectors? This is only magnitude. And you must have heard what are vectors. Vectors, they have both magnitude and direction. Both magnitude and direction. These quantities, vector quantities, have both magnitude and direction. And then another thing is there, let it be there, we will discuss that. Okay. And then there is another question. What is this magnitude and direction? Very simple. I would like to explain it by using a simple example. Look at this. So here I have one, what is this? This is a tester. So I am going to apply some force by using my hand. So it will move in that direction. Am I right? Okay. So let it be there. And in this second example, I am going to move it, push it from same force we are applying. But here I am applying. Okay. What will happen? It will move in this direction. What will happen if I move in this direction? It will move in that direction. What will happen here? So it will move in that towards you. Okay. So what will happen if I push it here? Okay, with the same force, nothing will happen. It will not move. I think you got it. So you think about it. In all these cases, I used same amount of force. I have used same amount of force. But the results, look at this, the results were different. For example, when I applied it here, it went in that direction. When I applied it here, it went towards, or it has come towards you. And if I applied here, it will come to go in that direction. So you cannot say that all the forces are same. Here all the forces are not same. Why? Because not only the magnitude, I told you same force only I applied. Same amount of force, quantity of force only I applied. But since the directions are different, we can say that all those things are, all those forces, they cause different result. Okay. So which means in the case of force, both magnitude and direction, both are equally important. Okay. But in the case of scalar quantity, only magnitude. What is magnitude? For example, you are going to a shop and you are asking 10 kilogram of rice. Okay. So this 10 kilogram, this is what is magnitude. Okay. For example, another example. So here, this is a body is here. So I am applying a force here. The force is actually 5 Newton. In lower classes, you must have studied that Newton is the unit of force. So I am applying a force here. So what will happen? This will move in this direction with some velocity v. So the question is, What is the magnitude here? 5 Newton is the magnitude. What is the direction here? You can say that towards this direction. That is the direction. So in which way you can actually say the direction perfectly? That direction is fine. There is nothing like, okay, you have to say direction in this manner. No. So you can actually decide in which way you have to see. Okay. So this is what is vector and scalar. And this is what you must have studied in lower classes, or you will study in normal classes. But this is not vector. This is not the complete vector definition. So scalar is okay, but vector, magnitude and direction, a physical quantity which has both magnitude and direction, you can call it as a vector. Okay, but there is a small problem. It's not a very small problem, it's a significant problem. Okay, so then I'll take one other example. In class 10th, you must have studied electricity, and this is actually 2 ampere, this is 3 ampere, this is 4 ampere. Okay, so 3 ampere is coming towards this junction, 3 ampere is coming, 4 ampere is going. So my question is, does this current does it have magnitude? Yes, it has. 3 ampere is the magnitude. 3 ampere is the magnitude. Question number 2. Does it have direction? Yes, it has direction. Towards the point, that is the direction. This is away from the point, away from the junction, that is the direction. So it has both magnitude and direction. So there is a question. Is it a vector? No. So it has both magnitude and direction, then it is not a vector. What does that mean? Which means there are quantities like this, current, and which has both magnitude and direction, but they are not vectors. Such quantities are known as tensors. For example, current is the best example. Then stress is the example. Okay, sorry, not stress, strain. Strain is the example, and some other examples are also there. And in this case, if you define a vector which has like both magnitude and direction, that is not absolutely correct, because that could be correct. Like you can say that, okay, I know the concept actually, like that you can say, but it is not absolutely correct. What you have to do is one more thing you have to add. It obeys vector law of addition. Vector law of addition or triangular law of addition. Triangular law of vector addition. It follows either vector law of addition or what is this? Triangular law of vector addition. But in the case of tensors, no vector addition or anything. We add them as just as real numbers. When you add real numbers, 2 plus 3, 4, this is going away, so it will be minus. So 2 plus 3 minus 4, that is the answer. But that is a net current. Okay, so and then the net current in the junction should be 0, right? Yeah, that's why that is KVL. You will study that in class 12. So this is 2 plus 3, so it will be like 1 ampere. Okay, let it be like that. Anyways, tensor you don't have to apply any vector law of addition. Then there is another question: what is vector law of addition? What is triangular law of vector addition? So that I will explain later. So, but right now you just keep in your mind. So this is what is a tensor, and this is what is vector and scalar. Okay. So I think you got the idea of vector and scalar. So vector you are not supposed to. If you were kids, I wouldn't even mind when you say that a vector has both magnitude and direction. But now you are in class 11th. Okay. So you are not supposed to say that. You have to add one more thing. This one. You got it? Alright.